Hi everyone, this is Mrs. G, and today we are going to be solving quadratic equations by factoring. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work. So here we are multiplying binomials. So remember, there's this process, some people call it FOIL, where you multiply the front terms together, the outside terms together, the inside and the last FOIL, and then you can combine like terms from there. So go ahead and check each step. Part C, just be careful. Remember, x minus 5 squared means x minus 5 times itself. You cannot distribute exponents to binomials. You actually have to multiply it out. So if you don't really stop and think about this one, you might say the answer is x squared minus 25. Remember, that's not how order of operations works. We need to multiply the entire thing by itself. Also, when we're multiplying out binomials, I do recommend taking this step where you're just multiplying each individual term and then combine like terms in the next step, and that will definitely help you avoid small mistakes. All right, so the reason why we started the warm-up with multiplying out binomials is because today we're going to be factoring. And factoring is kind of like the opposite of multiplying. We turn a larger expression into factors, things that can be multiplied together to give your original expression. So there's many different methods that we will use to factor quadratic equations. Today we're just working with quadratics. Here's some of these methods, and we'll review all of them. First thing, we'll always check for what's called the greatest common factor. I'll call it a GCF. So we're looking for the largest value or variable we could divide out of each term, and we'll move that out front. So we always check for this first. It doesn't always have one, but it's good to always look. And then we have a method that I like to call magic X. We use it for quadratics that look like this: ax squared plus bx plus c. But when your a value is equal to 1. So when the coefficient of x squared is 1, we can use this magic X method. But when the coefficient of x is greater than 1, it's a little trickier. There's lots of different methods we can do, but the one I like to use is called the bottom-up method. So I'll walk you guys through that. And then we're also going to look for difference of two squares, which is when you're subtracting two terms that are both perfect squares. So we'll review what that means. There's a little formula for it. So here's the formula. And then a couple things I want you to remember. Not all expressions are factorable. Factoring is a great way to solve quadratics, but there will be times when we cannot use factoring to help us solve. So if you're spending a lot of time trying to factor something and you can't figure out, it's very possible that it's just not factorable. So don't forget about this. And second, if your leading coefficient, meaning the coefficient of x squared, is negative, the first thing I would always do is factor it out. It's much easier to factor if this coefficient is positive. So those are my two tips for you guys. All right, so first we're going to review how to use a greatest common factor. So again, this is something we always check for in our first step. So you're going to look at every term in your expression. In part A, there's only two terms. You say, what do they have in common? What's the biggest thing I can divide out of both of them? So sometimes the GCF will involve a value or a constant, but in this case, there's nothing that they share. So sometimes it will actually be a variable. Both terms have at least one power of x. So the GCF in this case is actually x. So when you're using a GCF, you have to divide it out of every single term, and then you move that term out front. You can never lose your GCF. It's still part of your answer. And here you go. So here we have two factors. One of our factors is x, so x is a factor, and x minus 3, the entire thing, is a factor. The way you can check to see if your factors are correct is you can actually multiply it back out. So x times x is x squared, and x times negative 3 is negative 3x. So we know that we factored it correctly. Now let's look at this next one. So here, not all of my terms have x. These first two do, but this one doesn't. so we can't include x as part of our GCF. But one thing I do notice is that all three terms are divisible by 2, and that's the largest number they're divisible by. I also notice that the leading coefficient is negative, so I'm going to include that in my GCF. I'm going to factor out -2. So I'm dividing each term by -2, and I'm going to put that factor out front. And then I'm left with x squared, so positive x squared, and then positive 9x, and then -4. So here we have 2 factors. You could even think of it as 3 factors if you wanted to. You could say -1 is a factor, 2 is a factor, and x squared plus 9x minus 4 is a factor. We'd always look to see if we can factor this expression more. In this case, we can't, so we know that we're done. All right, so now please pause the video and give these 2 a try on your own. All right, go ahead and check here. So for part A, the largest thing that you can divide both terms is x. And remember, I also always recommend that you divide out the negative if your leading coefficient is negative. And for part B, your GCF here is 3, so you divide each term by 3. Make sure your answer has the GCF. The GCF is a factor, so it must be part of your answer. All right, so now we're going to move on to trinomial quadratic expressions. That's when you have 3 terms, trinomial, where your a value is 1. So remember, the a value is always the coefficient of x squared. So when you have a scenario like this, I like to use this method called magic x. So what I do is I actually draw an x, and I take my constant. The constant is the term without the variable, and I put it on top. And then I take my b value, which is always the coefficient of x, and I put it on the bottom. And then I'm looking for 2 terms or 2 numbers that multiply to make 5 and add to make 6. So to do this, you can just think of the factors of 5. Well, the only factors of 5 are 1 and 5. So 1 times 5 is 5. Oh, and conveniently, 1 plus 5 is 6. So I know that these 2 numbers are 1 and 5. Those are not my factors. So now I have to take those and turn them into factors by including them with x. So my first factor is x plus 1. And I do times my second factor, which is x plus 5. And there you go. So remember, my factors are not 1 and 5. My factors are x plus 1 and x plus 5. If we do a quick little double check, we have x squared plus 5x plus 1x plus 5, which gives us what we started with. All right, let's try this next one. So here we have to be a little more careful with our negatives. Our constant is -12, and our b value is -4. So again, we want to multiply to make -12 and add to make -4. So this means that one of our numbers must be negative, but not both and not neither. So I think of the factors of 12. Well, we have 12 and 1, but that wouldn't add up to 4. We have 4 and 3, but there's no way to add. -4 and 3 doesn't work. -3 and 4 doesn't work. So what are the other factors of 12? Oh, 6 and 2. So if I want it to add up to -4, I can do -6 and +2. So this multiplies to make -12 and adds to make -4. So my factors become x minus 6 and then times x plus 2. So notice when I read that out, I don't say parentheses x minus 6, parentheses, parentheses. I say x minus 6 times x plus 2. All right, let's try another one together here. So my c value is 9, my b value is -6. So what multiplies to make 9 and adds to make -6? So here, I'm multiplying 2 numbers to make a positive, but I'm adding 2 numbers to make a negative. So that actually tells me that both numbers have to be negative for this to work. So I think of the factors of 9. Well, we have 1 and 9, but that wouldn't work. And our other ones would be 3 and 3. So if you do -3 and -3, that works. A negative times a negative gives you a positive, and negative plus negative gives you a negative. So we have x minus 3 times x minus 3. So here you see that we have the same factor twice. So there's another way we can write this. We can write this as x minus 3 squared. So either way, is completely fine with me. I do just want to point out there are two different ways you can write this answer. All right, now let's look at this last one here. X squared plus 8x minus 20. So negative 20 is our C value, positive 8 is our B value. So I know that one of the terms must be negative and one must be positive to have a negative product, but the larger number should be positive because the sum is positive. So I think of the factors of 20, so I say 4 and 5, well that wouldn't work. 20 and 1, that wouldn't work. Oh, how about 10 and 2? So if I do a positive 10 and a negative 2, that meets our C and B values. So we have the factors x plus 10 and x minus 2. So remember, 10 is not a factor. Negative 2 is not a factor. X plus 10 is a factor. X minus 2 is a factor. And again, you can always do a quick double check by foiling it out to make sure your factors are correct. All right, go ahead and pause the video and give these two a try on your own. All right, go ahead and check your work here. For part A, we have x plus 5 squared, the same factor twice. And then for part B, we have x minus 8 times x plus 3. Check the signs of your factors. It should be x minus 8 and then x plus 3. All right, so now we're going to be factoring trinomial quadratic expressions, so 3 terms for the trinomial, and quadratic meaning it has an x squared term. But here we can see that our a value is greater than 1. So here we can't just use the magic x method. These are a little trickier. Now there are a lot of different methods that people use to factor this, so you are welcome to use whatever method works for you. Maybe even just kind of guessing and checking works. But I'm going to show you a method that I really like. It's called the bottom-up method. So when you see this scenario, the first thing I'm going to do is I'm going to take my a value and I'm going to temporarily multiply it to my c value. This is temporary. So x squared plus 7x plus 6. And I am not saying that this expression is equal to this expression. They're definitely not equal. This is just a little method that happens to work for these types of trinomials. So now I'm going to look at this remaining trinomial and I'm going to see if I can factor this using magic x, because now we've turned it into a trinomial where your a value is 1. So these we know how to factor. So what two numbers multiply to make 6 and add to make 7? We can do 6 and 1. So then I'm going to write my factors like this, but this is not my final answer. So with this method, it's really important that you don't stop here, because if you do, look at our first step of FOIL. X times x is x squared, not 2x squared. So there's definitely an issue here. This is not done. So here, since we multiplied by 2 at the beginning, we're going to divide both of these by 2 at the end. So again, this is just kind of like a method that just happens to work for these types of problems. So when I do this, I'm going to see if I can simplify. Like here, 6 divided by 2, I can simplify. So this term turns into x plus 3. But anytime I have a simplified fraction like 1 over 2, this is why we call it the bottom-up method. I'm going to take the number on the bottom and bring it up in front of x. So this becomes 2x plus 1. So if we double check this, we have x times 2x, which is 2x squared, and then we have plus x plus 6x, which is 7x, and then plus 3. So we can see that our factors are correct. Especially with these types of problems, I would definitely recommend doing a quick double check. And please don't forget this last step. If you leave your answers x plus 6 times x plus 1, that's not going to give you the trinomial we started with. All right, let's try another one together. So here I see that a value is greater than 1, so I'm going to try this method again. I'm going to temporarily take my a value, which this time is 3, and I'm going to multiply it to my c value. So x squared minus 2x minus 15. And then I'm going to see if this is something that I can factor. If this is not something you can factor, it just means your expression is not factorable. So what multiplies to make negative 15 and adds to make negative 2? So that'd be negative 5 and positive 3. So I have x minus 5 times x plus 3. But remember, I am not done. X times x is not 3x squared. So I have to go back to that a value, which in this case was 3, and I have to divide both of my terms by that. So here, I can't simplify this, so I'm going to take this bottom and move it up. So it becomes 3x minus 5. Now here, I can simplify this. We don't want to call this 3x plus 3. That wouldn't be correct. We actually want to simplify this. 3 divided by 3 is 1. So x plus 1. So let's double check. 3x times x is 3x squared. And then we have plus 3x minus 5x, which gives us negative 2x, and then minus 5. So our factors are correct. Again, we just cannot forget this last step of dividing out your a value. Okay, let's try one more together. Here, I can see that my a value is 4. So I'm going to take that and I'm going to multiply it to my c value just temporarily. X squared minus 4x minus 12. Again, I am not saying these two expressions are equal. They are definitely not. It's just for the bottom up method. Now I'm going to see if this is a factorable expression. So what multiplies to make negative 12 and adds to make negative 4? We can say negative 6 and positive 2. Okay. Now here we have to be extra careful because when we go and divide our a value out, which was 4, we're left with actually two fractions that you can simplify. So before you bring the 4 up, before you actually do the bottom up, you have to simplify your fractions. I'm going to put a star, and I'm going to write this note. I'd like you guys to do this too. Simplify fractions first, because if you forget to do this, your answer is going to be wrong. So 6 over 4 simplifies to 3 over 2 times x plus 1 over 2. But again, we're still not done. We still would not be able to multiply our binomials and get what we started with, right? X times x is still not 4x squared. So now we have to finish with bottom up. And this time there's going to be bottom up on both factors. So that gives us 2x minus 3 times 2x plus 1. Let's check our answer real quick. We have 2x times 2x is 4x squared. And then we have plus 2x minus 6x, which is negative 4x, and then minus 3. So this is definitely the trickiest that it gets. So again, sometimes after you've divided out your a value, you need to simplify your fractions before you do bottom up. And I do want to reiterate again, if there is a different method that you have for factoring these types of trinomials, you are more than welcome to use it. This is just one of many methods that works. All right, go ahead and pause the video and give this a try. I'd encourage you to try out bottom up method just to see if it's one that you like. All right, go ahead and check your work here. So for the first one, this 4 over 2 just simplifies to negative 2, and then here we'll do the 2x minus 5. Be careful with the second one. Once you've divided both terms by 6, 10 over 3, you need to simplify to 5 over 3. Sorry, 10 over 6 becomes 5 over 3. 9 over 6 becomes 3 over 2, and then you bring it bottom up. If you don't simplify first, you're not going to end up with the correct factors. There's only one correct answer here. There's only two factors that will multiply to make this trinomial. So it's not like you can have a different answer and still be correct. It doesn't matter which factor comes first. I do want to also point that out because you're multiplying. Doesn't matter which factor as long as the two factors are the same. All right, the last method that I want to talk about with you guys today is called difference of two squares. So this method is actually a formula, and it's just for very specific scenarios. The formula was on that first slide, but it looks like this. So when you have the difference of two perfect squares, difference meaning you're subtracting, and perfect squares meaning that you achieve them by multiplying the same value by itself. You can factor it with a little formula, a plus b times a minus b. So notice that this is a squared and this is a, which means this is the square root of a. And this is b squared and this is b. So that means b is the square root of b squared. I also want to point out that a and b, when I define what a and b are, they are always positive. This negative is just part of the expression. A and b are always positive here. Now, I want us to list out a couple perfect squares just so we all know what that means. Perfect squares. So ones that you should recognize, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and then we have 25, 36, 49, 64, 81, 100. I would also make sure you know 121, 144, and even 13 squared, 169 is a useful one to know. So if you see any of these numbers, hopefully they scream perfect square to you. Now for this method to work, again, both of the terms need to be perfect squares, both of them, and it needs to be a subtraction in between them, okay? So let's look at this first one. I do see that we have a difference of two squares scenario. So I like to define what a and b are. Since this is x squared, that means that a is just x. And this term is 81. Again, ignore the negative. That's just part of the formula. 81 is b squared, so that means that b is 9, because 9 squared is 81. So then I just do a plus b times a minus b. So it's x plus 9 times x minus 9. And again, you can multiply this out. You'll see that we get negative 9x plus 9x, so that's why there's no x term here, and then minus 81. All right, let's look at this next one. Here, I know that there's a coefficient in front of x squared, but as long as it's also a perfect square, we can still use difference of two squares. So these are both perfect squares. We're subtracting, so it's a difference. So I see that my a value is 2x, 2 squared is 4, x squared is x squared. And I see that my b value is going to be 5, because 5 squared is 25. Notice a and b again are always positive. And then I just do my a value plus my b value times a minus b. And I am done. All right, go ahead and pause the video and see if you can try these two on your own. All right, go ahead and check your work here. Please remember that 1 is a perfect square. We listed it out on the last slide. But so our a value is x, our b value is 1. And then for part b, our a value is going to be 8x, and our b value is going to be 7. Okay, so now that we've reviewed how to factor quadratic expressions, we're going to see, why do we care about factoring? And the reason why is we can use them to solve a quadratic equation. So now we're going to be adding in equal signs, and we're not just factoring, we're actually going to be solving for x. So here's the process here. This first step is extremely important. We need to make sure we set our equation equal to 0 before we factor. And then we factor the quadratic equation, and then we use what's called the zero product property to finish solving. That's where we set each factor equal to 0 separately, and we solve them individually. And I'll kind of walk us through the logic of that when we do our first example. So for these problems, it's very possible that we get 2 solutions. It's also possible that we get 1 solution or no real solutions. So later on in this chapter, actually really soon, we're going to talk about what are called imaginary or complex solutions, but for today, we're just going to be sticking to real solutions. All right, let's give 2 of these a try together. So you can see that step 1 is already done for us here. All of my terms are on one side and the other side is equal to 0. So I'm going to go through my checklist. My first thing that I always check for first is a GCF. In this case, there's nothing that all three terms have in common. So I can move on to deciding what my process should be for this one. It is a trinomial, and my a value is 1. So this is going to be a magic x problem. So sometimes for these problems, just determining what method to use is the trickiest part. So here, I'm going to try to factor that expression on the left. So what multiplies to make negative 32 and adds to make negative 14. So if you go through the factors of 32, you have 1 and 32. I know it's even, so I know 2 and 16 would be the next one. So that actually works. We can do negative 16 and positive 2. So it becomes x minus 16 times x plus 2 equals 0. Every single step must have an equal sign. I will absolutely ding you if any step loses the equal sign, because if you lose the equal sign, it's no longer an equation and you can't solve. So here we're going to move on to what's called, again, that zero product property. I usually like to abbreviate it with ZPP. So the logic here is that since these two things are being multiplied together, we know that anything times 0 equals 0. So if this first factor equals 0, doesn't matter what this is, the whole thing will equal 0. And if this second factor equals 0, it doesn't matter what the first factor is, it will still equal 0. Again, multiplying by 0 gives you 0. So for the zero product property, we want to take each factor separately and set it equal to 0, and this is absolutely a step I need you to show. And then from there, we just finish solving. So we get x equals 16 and x equals negative 2. So here we have two solutions. You could always double check your solutions by plugging them into the equation and see if you get a true statement. All right, let's move on to part B. So first here, you can see that our equation is not equal to 0. So let's do that first. We'd like the coefficient of x squared to be positive, so I'm actually going to add it to this side, and then I will also add 9x to both sides. So that will give us positive x squared plus 9x plus 18 equals 0. So again, I added x squared to both sides, and I added 9x to both sides. And then I just put it back on the left side of my equation. It doesn't matter what side of the equation it's on. Okay, now I'm going to look and try to decide what method I should use to factor. Again, it's a trinomial. My a value is 1. So I'm going to try the magic x method. Again, not every equation or expression is factorable. But if it is, it's definitely the easiest method to solving. Okay, so what multiplies to get 18 and adds to make 9? That would be positive 6 and positive 3. So x plus 6 times x plus 3 equals 0. You cannot lose your equal sign. From here, let's move on to zero product property. So I would again like you to show this step. You need to show this step where you set each factor equal to 0 separately, and then from there you can finish solving. So we get x equals negative 6 and x equals negative 3. All right, let's try two more together here. So first thing I'm going to do here is set my equation equal to 0. My x squared term is already positive, so I'd like to leave it alone. So let's move everything else to the same side. So I'm going to add 10x to both sides and then subtract 15 from both sides. Now here, remember, the first thing we always check for is a GCF. And in this case, we do have one. Our GCF is equal to 5. All three terms are divisible by 5, and I'm going to put that 5 out front. So leaving us with x squared plus 2x minus 3 equals 0. But then once I've done that, I'm going to see if I can factor more. So I'm going to focus on this trinomial now. And I see it's a quadratic trinomial with an a value equal to 1. So for this piece specifically, now I'm going to try to use magic x. So I'm going to say, well, what multiplies to make negative 3? and adds to make positive 2. We can do 3 and negative 1. So I have 5 times x plus 3 times x minus 1 equals 0. So from here we can do the zero product property. Now whenever you have a factor like 5 that is just a constant, meaning there's no variable, this factor is not going to give us a solution. I could still set it equal to 0, but 5 is never going to equal 0. So a constant factor will not give you a solution. You don't have to show that step. But here, you do need to show that you are setting your other two factors equal to 0 separately, and then you can finish solving from there. So x equals negative 3, and x equals positive 1. So again, don't forget to always check for a GCF first. So here you can see we actually have a multi-step factoring problem. So sometimes you will have to use 2 or maybe even more methods of factoring before you can get to the zero product property. All right, let's try this last one together. So here, this is a quadratic equation. It's not a trinomial, so I'm not going to be using magic x or bottom up, but I will always check for that GCF first, which we do have in this case. Our GCF is 3. So let's divide that factor out. So 3 times 4x squared minus 1. So now here I ask myself, can I factor more? And in this case, I can. This is difference of two squares. I like to call it dots, difference of two squares. Because 4 is a perfect square, x squared is a perfect square, 1 is a perfect square, and I'm subtracting. So I can see that my a value is going to be 2x. My b value is going to be 1. So I'm left with 3 times 2x plus 1 times 2x minus 1 equals 0. Please don't forget that. So here, we don't need to set our factor equal to 0. In fact, if you have a constant factor, meaning a factor with no x in it, we can actually divide it out of our equation altogether. This is an optional step. I just want to show you, you can do it. You can never, ever, ever divide both sides by x. So if your factor has an x in it, you cannot divide it out. But if it's a constant factor, you're more than welcome to do this, or you can just leave it out front. It doesn't matter. So now I can move on to the zero product property, where I set each factor equal to 0 separately. Here it's going to take me 2 steps to finish solving, but nothing too tricky. So I get x equals negative 1/2 and x equals positive 1/2. So here again, we have another 2-step equation. So you have to go through your checklist. Does it have a GCF? And you say, okay, can I use magic x? Can I use bottom up? Can I use difference of two squares? And then hopefully you get some nice factors, and you could use zero product property to solve. All right, here's our last 2 problems for you to try. So pause the video and give it a shot. All right, go ahead and check your work. So for part A, make sure you set your equation equal to 0 first, and then hopefully you notice that this would be a bottom-up scenario because that a value is greater than 1. So here's my process. You'll see in this process, I did not set my equation equal to 0 because this is not equal to my equation. It's just part of the process. But once I have my factors, x plus 1 times 2x plus 1, I then set that equal to 0. And then from there, I have my zero product property, and I set each factor equal to 0 separately. For part B, if you remember that tip where if your leading coefficient is negative, factor it out, or you could even divide both sides by -1. If you do that first, then you'll see that what's remaining is a difference of two squares quadratic expression. So our a value is x, our b value is 6. So we have a plus b times a minus b, then a little zero product property, and we are all done. All right, that is all for today's video. Thank you so much for watching.